Let's continue with section 1.6. Adjacent angles. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. Let's use this diagram to show some examples. Here I have angle TPQ. I also have an angle QPS. And we want to determine if they are adjacent. One, are they coplanar? Yes, they're in the plane of the whiteboard. Two, do they have a common side? The common side is ray PQ, so that is also true. And they have a common vertex. The common vertex is point P. And do they have any common interior points? The interior points to TPQ are generated inside of this angle, and inside of QPS are inside of this angle. Therefore, they have no interior points in common. So the answer is yes, they are adjacent. I could take a look at angle TPQ and SPR. Let's go through the same format. Are they coplanar? The answer is yes. Do they have a common side? They do not have a common side. The sides for TPQ are PT and PQ, and the sides for SPR are PS and PR. So therefore, they don't have a common side, so they are not adjacent. Let's take a look at another example. Here I have angle TPS. And I want to see if that angle is adjacent to angle TPQ. Going back through our definition, are the two angles coplanar? The answer is yes, they're in the plane of the whiteboard. Do they have a common side? They both have side PT. And they also have a common vertex. The vertex is point P. But what they have are points that are common to the interior of the angle. For example, TPS has the points that are in TPQ. Therefore, they share interior points. So therefore, these are not adjacent angles. Let's use this diagram to answer some questions. Name an angle adjacent to angle AOD. Here is angle AOD. I need an angle that has a common vertex and a common side, but don't share interior points in common, but also are coplanar. I'm going to use angle AOB. The common side, OA. The common vertex, point O. They don't have interior points in common, and they are on the same plane. Name an angle adjacent to angle AOC. Here is AOC. Again, I need an angle with a common side, common vertex, and no interior points. I'm going to name angle DOA. I have a common side of OA, common vertex of O, no interior points in common, and they are on the same plane. Name an angle adjacent to angle AOB. Here's AOB. I can select two different angles, one on the left side and one on the right. I'm going to select the one on the right, which is angle BOC. I have a common side of OB, common vertex, and no interior points in common, and they are coplanar. Last, name an angle adjacent to BOC. Here's angle BOC. I could use the one given in the previous example, but I'm going to select another one. I'm going to select angle DOB. Again, I still have a common side of OB. I have a common vertex and no common interior points, and they are coplanar. Therefore, they are adjacent. Vertical angles. Vertical angles are formed by two intersecting lines, and they are non-adjacent angles. If I choose angle 1 and want an angle vertical to that, I cannot choose 2 or 4 because 2 and 4 are adjacent angles to 1. Therefore, the only other angle that would pair with angle 1 is angle 3. These are vertical angles. If I select angle 2, the only non-adjacent angle in the diagram to angle 2 would be angle 4. Therefore, they are vertical angles. The key to remember about vertical angles is that they are congruent. Therefore, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Let's do two examples. Find the measure of angle 1. Since angle 1 and angle 42 are vertical, therefore I know they are congruent. So angle 1 equals 42 degrees. The second one, the measure of angle 1 must be congruent to its vertical angle. Therefore, it's congruent to a 127 degree angle. Therefore, the measure of angle 1 is 127 degrees. Next, complementary angles. Two angles whose sum is 90 degrees. Here, I have a diagram that angle 1 and 2 are complementary. If I add angle 1 plus angle 2, they will add up to 90 degrees. Therefore, they are complementary. Here, angle 1 and angle 2 are adjacent. In the next diagram, I have angle ABC and angle XYZ are complementary. Therefore, if I add up these two angles, 25 degrees plus 65 degrees, they will add up to 90 degrees. Therefore, these two angles are complementary. This just tells me that the angles that are complementary can be adjacent or they can be non-adjacent. Next, supplementary. The same idea as complementary, except these two angles have a sum of 180 degrees. Like on our previous slide, I had a right angle designated by the red box, and I knew that that would add up to 90 degrees. Here, I'm given a straight angle. Therefore, I know that angle 1 plus angle 2 must equal 180 degrees. Therefore, these two adjacent angles are supplementary. Here I have two non-adjacent angles, but they tell me that they are supplementary. So if I would add up 24 degrees plus 150 degrees, I would get 180 degrees. Therefore, I know that I can have supplementary angles that are adjacent and also non-adjacent. Let's use this diagram to answer some questions. Here, name two right angles. Well, I know the one that has a red box in it is a right angle. Therefore, I could name that angle CDE, or I also could name that angle 3. But I also know that ADE is a straight angle. So if this is 90 degrees, this would have to be 90 degrees because the entire straight angle is 180. Therefore, I know that angle ADC is a right angle. Next, name two straight angles. They would be the two straight lines. That would be angle ADE and angle BDF. Name two pair of vertical angles. Recall they are formed by two intersecting lines and are non-adjacent. If I choose angle 1, I need an angle that is non-adjacent to it, but is formed by these two lines. 2 and 3 form one angle that is adjacent to angle 1. 5 is the other. Therefore, angle 4 is the non-adjacent angle. Therefore, it is the vertical angle to 1. Angle 5, its non-adjacent angle are these two angles, 2 and 3, which make up angle BDE. Name two pair of adjacent angles. The easiest, angle 1 and angle 2. Also, angle 1 and angle 5. But there are many choices for adjacent angles. Let's continue with this diagram. Name a pair of complementary angles. Since this angle is a right angle, I know that this angle is a right angle. If that is true, the sum of these two angles is 90 degrees. Therefore, angle 1 and angle 2 are complementary. Name two pair of supplementary angles. Here, the key is to look for a straight line. I'm going to choose angle BDF as my straight line. The two angles that form BDF are 1 and 5. Therefore, their sum is 180 degrees. They are supplementary. This straight line BDF also has supplementary angles on the other side. They are angle BDC and angle CDF. And there are different ones I could select on this side that form 180 degrees. I also could have chosen angle ADE and selected angle 4 and 5 as supplementary, and then also angles that are on top of ADE. Next, name 3 angles whose sum is 180 degrees. Again, I need to have a straight line. So ADE would be the angle that I select, and the 3 angles that form that are 1, 2, and 3. So angle 1, angle 2, and angle 3 would add up to 180 degrees. These cannot be supplementary because supplementary angles only call for 2 angles. Here we have 3. Using the next diagram, we're given that the measure of angle 1 is 46 degrees. And they want us to find the measure of each numbered angle. Here, we're given 2 straight lines. And I know that angle 1 and angle 3 are vertical angles. Therefore, angle 1 is congruent to angle 3. Therefore, the measure of angle 3 must be 46 degrees. If I use this as a straight line, I know that angle 3 and angle 4 are supplementary. Therefore, angle 3 plus angle 4 must add up to 180 degrees. Substituting, I get angle 3 to be 46 degrees plus angle 4 equals 180 degrees. Then when I solve, angle 4 is going to equal 134 degrees. And I know that angle 4 and angle 2 are vertical angles. Therefore, angle 4 is congruent to angle 2. So, if angle 4 is 134 degrees, so is angle 2. Here, we want to use this diagram to see if we can make each conclusion in the diagram. Number 1, angle 6 plus angle 7 equals 180 degrees. Here, BDE is a straight angle, therefore these two would be supplementary and they would equal 180 degrees. The answer is yes. That's number 2, segment AC congruent to segment BD. In the diagram, we don't have tick marks to represent their congruency, so we have no idea if they are congruent, so the answer is no. Number 3, segment AB is congruent to segment CD. Notice we have a single tick mark on each segment to represent that they are congruent. Therefore, we can say yes to number 3. Number 4, angle 1 is congruent to angle 6. In the diagram, these are non-adjacent angles, they are not vertical, and we know nothing else about angle 1 and 6. Therefore, we cannot make this conclusion. Number 5, angle 2 congruent to angle 5. Here, we have an arc in each one of those represented angles. Therefore, that tells us that they are congruent. We can say that number 5 is true. Number 6, is point D a midpoint? That's a point that divides a segment into 2 congruent segments. Here, I have BD and DE being congruent because they show 2 tick marks for each one of those segments. So therefore, point D is a midpoint. Number 7, is BD congruent to DE? We've answered yes to the previous question, therefore this has to be true. So yes, those segments are congruent. Also, they are represented by 2 tick marks on each segment. 8, angle BDE is a straight angle. Yes, that is a straight angle and it forms 180 degrees. Number 9, angle 4 plus angle 5 equals angle ACD. That is true. These 2 angles, if I put them together, would form the large angle, which is the angle addition postulate. So that is true, yes. Number 10, angle 5 and angle 6 are adjacent angles. Angle 5 and angle 6 do share a common side. They are in the same plane, but they do not have a common vertex. 5 has a vertex of C, 6 has a vertex of D. Therefore, the answer is no.